Hello everybody, welcome to my channel. This is a new video tutorial of database. The database could be RDS, DynamoDB, or QLDB. In this video tutorial series, I will teach you how database works and how to use my RDS with Blueprint plugin, DynamoDB with Blueprint plugin, and QLDB with Blueprint plugin. In the very beginning of this video tutorial series, let's begin with some basic concepts. First, let's talk about table. When we design a table, the table should be able to insert, update, delete, and query its data as fast as possible. That's why we need the table tool. Normally, we call insert, update, and delete operation as write operation and query as read operation. Here is a table of students in a class. We can insert new students into the table by appending them at the end of the table. We can insert the data very fast. Now, there are many students in a class and the table is out of order. When we want to find a student named Lion, we need to check every line in the table. It will waste a lot of time. So as update and delete, we need to find a student to update or delete his data. Let's sort them alphabetically. Now, when you want to find a student named Lion, we just need to shift to name started from L and just check students whose name started with L. This is called indexing. We can also sort students with their age or gender. When we sort them by age, there are some students have same age. So, we can sort their name alphabetically after we sort them by age. Index can sort multiple columns in order. When we create an index for a table, we also create a new table for the index. We can imagine a dictionary. Words in the dictionary are sorted alphabetically from the first character. Now, let's create a dictionary that sorts words by its length first, then alphabetically. Don't we need to create another dictionary? In database, tables for indexes are much smaller because all records will be represented by a link. But without an index, we need to check all records when we need to look for what we want in the table. It will take much more time than indexes. So, we always need to find a balance between more indexes but faster querying or smaller database but slower querying. In order to keep records sorted in the table, when we add new records in the table, we need to find the place the record is supposed to be in all indexing tables. Now, the index operation need to find a student first too. But delete, update operation, and query operation will be faster. There is one more problem when we design a table. What if there are two students in the class has the same name, Lion? It's hard to identify each other if we just use their name to call each other. In order to facilitate the record, we need to number them. This is primary key. Finding a record with primary key normally will be faster than finding any other column. So, we can use primary key for delete and update operation. We can use primary key to represent a student. For example, when I want to create another table to record result of a math exam, we can just use the primary key to represent the student in the table. It's called foreigner key in the result of math exam table. Each table can set up relationship with any other tables. So, we call it relational database. This is SQL, which is used in RDS with Blueprint plugin. There are many kinds of database in the world. They are divided into many categories. The most mainstream classification method divides them into two categories, SQL and NoSQL. I have talked about SQL in the last page. Let's talk about NoSQL. NoSQL is also subdivided into many types. When we use SQL, we notice the problem. Even though indexes will help reducing the query time, if there are many indexes for a table, when we insert a record into the table, it will take a lot of time finding its place in all indexes. So, insert speed will be awful. So, people designed a simple system to take care of query and insert speed. First, we removed indexes and only keep Unicode ID as primary key. This is the most common form of NoSQL. For example, Redis and Memcache. When we want to get a student from the table, we need to use the primary key to retrieve it. It's still fast query if we query the table by the primary key. But if we want to get a list of students whose age is 30 years old, we need to root the whole table, and the table will be very slim. But we still want to use query and want fast query instead of root the whole table. So, partition key and sort key is created. It simplified the index feature for NoSQL. Still consider the student in the class. We divide the student into multi-partition based on their gender. Then sort them by their age. When we query with partition key and sort key, we need to tell which partition exactly we are looking for. Partition key can be used for comparison and sorting. We can use partition key and sort key to get male students who is older than 14 years old and sort the result by age. When we create index for NoSQL, normally partition key is required and sort key is option, and you can only add 2 columns to the index. This is how DynamoDB works. It's also called key value database. In DynamoDB, primary key is also defined as partition key and sort key. It's called primary partition key and primary sort key. We can define the student's family name as primary partition key and given name as primary sort key. But there might be 2 students have a same given name and family name. So, normally, we still use an auto-increment ID as primary partition key without sort key if we design a table for student. Compared to SQL, key value database has simplified index or even doesn't have index system. Its insert speed will be faster. If the data you want to query can be generalized as partition key and sort key, you won't sacrifice any query speed. There is another way to speed up the write and read operation of a database instead of changing its architecture, saving it in RAM. It's called in-memory database. Redis and Memcache mentioned above is the most popular in-memory database. Because the data in RAM can't be persisted, we always need to use another database service to persist the data. But sometimes we need our database much faster. We don't want indexes and even primary key. We don't care about query. We can just use first in, first out, or first in, last out. When the insert operation comes, we just want to push it into database immediately and ready to handle next incoming data as soon as possible. So, we removed everything and just left the value. No primary key, no index. It looks like a ledger, just record the event. So, it's also called ledger database. The most well-known ledger database is Kafka. QLDB is a ledger database too. Normally, the data in ledger database is out of order. They are just placed in the database, sorted by when the database service handles the data. And we read the data one by one and first in, first out. QLDB has a simple index feature, but it only supports a single column. It's simpler than DynamoDB's indexes. We normally won't query or update or delete data in ledger database. It violates ledger database original intention. We just write and read the data in ledger database first in, first out like a pipe. So, it's also called immutable database. Last, let's talk about database practice. When we design a database system, there is not always a best practice. We always need to pick one solution that best fits what we need. If you have used your database for many years, you will find that nowadays, databases are more and more look like each other. For example, MySQL just added the JSON data type, which allows it to work as a key value database. More and more ledger databases started to add indexes support. The boundaries between different database classifications are beginning to blur. So, which kind of database service you want to use will also make the final design of your database system different. Normally, when we design a database system, we start with the main database. For main database, we usually choose SQL, for example, RDS, or not in-memory key value NoSQL with indexes support, for example, DynamoDB. We normally will call write operation including insert, update, delete as front end, and read operation as back end. When player number increases, the number of write operations or read operations or both will increase and their speed will slow down and will increase your cost. If write operations start slowing down, we will add the front end database. For the front end database, usually choose ledger database, for example, QLDB. All write operations will be sent to QLDB. Then we need to set our worker service. We can use AWS Lambda service. We use the worker service to read the data from QLDB, then run the data into main database with an affordable frequency. It's called consume in terminology. The data in ledger database normally will be deleted after consume or after a certain day or when the table is larger than its disk quota. For example, Kafka will delete the data after a retention time, or the table, we call it topic, is larger than its disk quota. Because most of applications have more users at daytime and have less users at nighttime. So, the unconsumed data in QLDB will be reaching during daytime and reducing during nighttime. The data that generated in a day should be finished pushing into main database in a day too. If read operations start slowing down, we will add a backend database. For backend database, we usually choose in-memory database, for example, Redis and Memcache. All read operations will be sent to in-memory database first to see if it has already read recently. If it is, then just return the last result. If it isn't, then query from main database and push the result into in-memory database for the next query. Developers normally use this method to design leaderboard systems or any other kind of system that doesn't require update immediately. For the system that need to be updated immediately, we will just read directly from main database. So, we always need to prevent making a system that requires immediate update. That's all. Thank you for your watching.